Hello, I'm Jim Webb, and today we're going to be talking about power supplies in Chapter 7. More power to you. So we're going to look at electrical basics. Um, if you think you know it, take some time to make sure you know it. This is one of the few things in computer science that'll hurt you. We'll also look at how we power a PC, install and maintain power supplies, also how to troubleshoot these. Now, things to remember. Every computer has a power supply unit. It takes wall power at 115 volts, 60 hertz, and converts it to 5 volts of direct current. It is something that you need to carry with you, because these do fail, as a field replacement unit. Voltage is the pressure of electrons in a wire, measured in volts. There's actually a guy named Volta. Then current, or amperage, is the amount of electrons moving past a point in the wire. Wattage is the amount of amps and volts needed so a device will function. And there are beautiful mathematical equations. The watts equal the volts times the amps. Resistance is opposition to the flow of the electrons. If there's no resistance, it's a supercomputer. If there's high resistance, it will cause the wires to get very hot. We measure resistance in ohms. Now, wires have amperage ratings, determine how much current they can carry. It's rated in amps, and you'll have fuse on those. If you exceed that, the wires will heat up and cause a fire or break. Circuit breakers are heat-sensitive or electromagnetically operated switches rated for a specific amperage. When you go past the number of amps, or the resistance, it basically trips the breaker. In the old years, when I was a child, we had fuses. And if you went past it, it would blow a fuse. You would have to go to McDonald's drugstore and get a fuse to replace it. Fuses are still used in power supplies so that you don't burn up your computer accidentally. Now, two types of current: alternating and direct current. They actually had a great movie about that called, what was it? Tesla and, the other guy, and it was a great movie. So AC, generated by turning a big bundle of wire in a magnetic field. Okay, direct current is a direct flow. It's used by batteries, solar power, etc. Now, the way this works: direct current goes one way all the time. Alternating current goes back and forth at 60 cycles per second. You'll know that if you stuck your finger in a light socket. Do not do it for this class. Now, the PCs use DC voltage. Power companies supply AC. So we have to take the PCs, hook them up with a power supply that converts AC to DC, and that's what your power supply is. Now, in the United States, we use 115 volts. If you go offshore, it's not unusual to see 220, 230 volts. We did it first, so I guess we did it right. Now, the standard connector is an IEC 320. It connects the power supply to the power cord, and let's see, yep, 110, 120 volts. Most of the world uses 220 to 240. Most power supplies come with a little red switch in the back, and you can flip it between the two. So if you take the computer offshore, or somebody wants to buy power supplies in another country, one size works for everybody. Now, key thing here: the hot and neutral provide a path for the AC. Okay, so we see hot on one side, neutral on the other, and it has 150 volts. So it moves across the circuit, so to speak. The ground is used for safety. If something bad happens, you get a short circuit, it will go to ground instead of causing a fire. Now, we have tons of tools. Okay, here's a multimeter, and you can measure continuity, resistance, AC, DC voltage, and if you use these correctly, that's a great tool. If you use it improperly, it'll burn up on you. Here we go. And they don't have to be expensive. Here, instead of an expensive digital, just a standard manual. Now, To see if something's working, let's say AC, set the multimeter to test AC, put the leads in electrical outlet, and what's the voltage between hot and neutral, hot to ground, voltage between neutral and ground. Does the outlet have the proper polarity? Okay. I wouldn't stick this, but try this on an electrical socket, take my word for it. You can also test the voltage on a cord. Now, verify wiring of outlet. So put one lead in hot, okay, the other the ground, and it should read 110 to 120 volts. I like this better than a test kit. You simply plug this in, and here is the codes, and it will tell you whether it's working or it's not. These go south on you sometimes. Don't make them like they used to. So it's pretty important to have one of these around. That's the first part of checking your computer, is the socket working. Now, power companies have imperfect power. The voltage will differ. It'll drag, sag, and it will spike. We're in Texas, so we have storms, so you'll see spikes and drops. Also, the construction areas are rough. Two essential things that happen when it spikes is it can cause your computer to malfunction or even burn up. You get around that by using a surge suppressor. Note the word suppressor. It will help suppress it, won't stop it, and an UPC, uninterruptible power supply. The surge suppressors help protect against power surges, okay, and it's between the power supply and the outlet. You measure them in joules, and that's how much of a surge it can handle. The higher the rating, the better protection. Other things also need protection. Phone lines, modems, DSL, cable modems, and they have surge protectors with attachments for them. Here we go. Here's one that's got them for cables. Let's see here, just a surge protector. A UPS provides protection against a power sag or power outage. It's basically a big battery. The battery has an inverter, and then the inverter supplies DC power. If you have a surge or it goes out, these universal power supplies can keep going for a little bit, and if need be, they could turn the system off automatically. They don't last for a long time. However, they're good for a short-term power outage. There we go. Here's a nice picture of them. So, the more expensive, the longer it will last. The longer it lasts, the more expensive. Okay. So here we got 3 brands, 3 models. They're all protecting a number of sockets at 120 volts. But look at how long these things last. If you want one that's going to go a long time, 18 minutes is a long time, it's close to $400. However, if your router's doing something that's very important, this might be a good investment, or to have alternate power supplies. So it can volts 110 AC current to 5, 12, and 3.3 volts. The PCs use 12 volts for motors, okay, on hard drives, optical drives, and they use 5 volts to support the onboard electronics. Usually this will be through a Molex or SATA, okay, and then we'll have a plug-in directly to the motherboard, 20, 24 pins, and then another one at 4, 6, or 8 pins. So here's a typical power supply. Notice it's got all kinds of things coming out of it. We'll go into those in detail. So power to the motherboard, usually 24 pins at this point, and there's usually a requirement to power the CPU and or video, and that'll be a 4, 6, or 8 pin connector. The types of connectors that will go into most of the devices are Molex or SATA. There's a mini, but that generally isn't used too often. The Molex, it's a legacy tool, supplies 5 and 12 volt power, and it's notched so it can only go in one way. The mini connector, which was used for the floppy disks, is still there. Notice it will only go in one way. Then the SATA power connectors. Notice there's a special name for the older ones, Molex, but SATA has to use the same name as the cables. So they're used for serial drives. Now this is what's cool. It's a 15-pin connector. And remember that the SATA data cable only has 7 wires. Supports hot swappable features, meaning you can plug them in while the computer's on. You can also get all kinds of splitters and adapters so that you can take Molex to SATA, split a SATA, split a Molex to SATA. And the SATA are L-shaped, almost impossible to insert incorrectly. Here's some pictures of them. Now, the original power supplies were kind of difficult. All right, when you turned off an AT, you had a key like a gun safe, and it turned off physically. With the ATX, we had what was called power or soft power. We could use the BIOS or the operating system to turn the PC off. Now, ATX systems are always on when plugged in. The 5-volt motherboard, when it's plugged in, can go dormant. Most important settings for the ATX soft power are in the CMOS setup. They have a whole power management system. Here goes a picture of it. Now, been a lot of versions. The first one, ATX 12 volt. Okay, it was called P4 power. And then another one, EPS 12 volt, used for server motherboards. Here it had what was called rails, a little different power system. The rails, it's a single transformer to make the AC current from a wall socket, converts it into DC, and it splits into 3 primary voltages, 12, 5, and 3.3, which we covered. The single rail system has a single overcurrent protector monitor, and the multi-rail system provides each pathway with its own overcurrent protection monitor. Now, the most current version is a 24-pin connector, or sometimes you'll have a 20 and then an optional 4-pin that plugs into the 20. It requires 12-volt rails for power. Okay, and let's see, power supplies rated than 230 rails should not draw power from each other. Yeah, and it has the pins for the CPU power connector. There we go. There's a good look at it. 20 and then that 4 kind of snaps on the end. Then the PCI Express 6-pin power connector, which powers your CPU. And then there's all kinds of niche power supplies. Here's a note. If it's a niche power supply, you're not going to get a replacement. You'll have to buy a new system. They're pretty good, but usually they're for smaller or specialty systems. Okay. And then we have something called active power factor correction. And it eliminates harmonics. Let's just say it doesn't vibrate. There we go. And there's Antec, a very big supplier. Now, wattage requirements. What do you need to run a computer? Most power supplies today will run somewhere between 400 to 1,000 watts. They don't run at 100% efficiency. So if you're putting a bunch of stuff on it, a bunch of drives, etc., you probably want to go up to the higher 750, 1,000. If you're just running a basic computer, you'll probably be able to get by with 500 watts. Now, installing power supplies, basically, you unplug the system from the wall. Repeat, unplug it from the wall. In the back, there are 4 standard screws. You simply remove those, and then you can pull it out. To install, put the new one in and replace the screws. There we go. Here's a picture of it. There you go. Here's your on-off switch, or 1, 0. Get that 1 is on, 0 is off. And then we'll look at this in lab. You can jump a computer to make it work without the on-off switch going. Then cooling. Power supply has to have a fan. If the fan breaks, get rid of the power supply. You can repair a lot of things, not the power supply. Do not play with electricity unless you're a seasoned, trained professional. It's safer and cheaper just to get rid of it. Okay. Here we go. Here's a big fan. They also get cluttered in Texas with all the dust. Case fans are for cooling key components. Most computers will have a fan for the system. They'll have a fan on the microprocessor on top of a heat sink. So you want to make sure that it can vent the hot air Warm air rises, don't cover the top, and make sure that the vents are available. There we go, case fan. Then reducing fan noise. Larger fans are quieter, slower fans are quieter than high-speed fans. Good bearings, etc. will help. Then CMOS fans. You can actually look at the temperature and fan speeds using your CMOS and have them come on if needed, or increase speed to control your heat. There you go. Here's a nice one. It tells you speed for the CPU, etc., how much you want to do with it. And you can even buy additional software and hardware for this, additional fans. Now, troubleshooting power supplies. The fan doesn't turn and there's no voltage, get rid of it. If it starts working intermittently, get rid of it. If the power supply is not functioning, get rid of it. It's cheaper to get a new one than a new motherboard and processor and video card. Now, you can buy a power supply tester. It's cool. You just pull the cables off the motherboard, stick them in the tester, and it will tell you which ones are working, which ones aren't, and even give you the voltage. Now, sometimes problems occur, and sometimes they don't. Probably want to look at the power supply first. If it's random lockups and reboots, it could be a power supply problem. Now, reasons that a fuse blows. The power supply is malfunctioning. Okay. And let's see here, you got too much junk on your computer. Now, putting it out with fire extinguishers. Oh, this is a cool area. I've had to put out several fires during emergencies. You want to know which one is appropriate. Class A, ordinary combustibles. Okay, don't use that for electrical stuff. Class B, flammables, such as gasoline. Class C, live electrical equipment. This is the one you want to have in a computer lab. Class D, titanium or magnesium. And Class K, all right, cooking oils. All right, you can actually get modular power supplies, or modular. Here, you simply plug them in, and you have just enough cable to do whatever you want. And it provides power in warmer temperatures, okay? So make sure it's well cooled.